Okay, so this is an older video. If older recording audio bleeds through, then you'll have to forgive me, and I'm going to get distracted. These are graphs that we have discussed before, linear, quadratic, and cubic. We're not going to use the names quartic and quintic. That's why they are highlighted. And we've discussed their end behavior, the intervals where they're increasing and decreasing, and most importantly, end behavior, which is what we're going to discuss in these sections. All right, so the little girls I used, and they're going to pop back up, and I'll change the screen back. Like I said, this is an old recording, so I'm at the mercy of what I did a couple of years ago. So we're talking about odd behavior, so that's the linear, cubic, and this quintic function, degree 5. So when you have a leading coefficient that's positive or a leading coefficient that's negative, you're going to see that you have a pattern of behavior at the ends. So that's why the two girls are there. So when we get back to the girls, you'll see the notes there for when you will have a hand up, hand down from left to right, or hands are down up and then up down. And that, if you will think about the linear graph, if this is a line, this would be positive slope, rising left to right. So this would be a positive leading coefficient. This would be a negative leading coefficient. So even if you've got the crazy, really curvy graphs, that would be positive leading coefficient. This would be negative leading coefficient. So whether it's a first degree, third degree, fifth degree, seventh degree, ninth degree, these would be your end behaviors. So I did a lot of these, like signing in person with the kids, and so I had drawn the little girls, and so they liked it in the notes. Take it or leave it. This is for even, so imagine my arms are the quadratic graph, so the U shape. So this would be positive leading coefficient, so facing up, and this would be facing down. And imagine, even though you have all these other hills, for a fourth degree or a sixth degree, this would also tell you about your leading coefficient, whether you got all those curves in it or not. For even, they have the same end behavior. And remember all the crazy end behavior when we discussed as x is approaching negative infinity or x is approaching positive infinity? And really all this meant was, on the left, what is your graph doing? On the right, what is your graph doing? And that is what we're going to go back to that once again. So we're going to revisit the end behavior and stating end behavior. We are also, let me go ahead and skip ahead if I can. I'm talky. The most number of zeros that you can have depends on your degree. If you have an odd power, so third degree, fifth degree, you can have an odd number of zeros. You will always have at least one because it's going to cross the x-axis because it's pointing in different directions. I believe we discussed this before. And then you have a maximum possible number of zeros depending on your degree. So if you had a third degree, the maximum possible number of zeros that you could have would be third, and then all the way down to 1. You are not going to have an even number of zeros for an odd degree function. And the same with even degree polynomials. You're not going to have an odd degree number of zeros crossing the x-axis for something to the second power, something to the fourth power, or the sixth power. It is either going to be entirely below or above the x-axis because of the shape of the graph, because both ends are going the same way. So all of its hills will be above or below, or crossing right in the middle, if that's where it happens to be. So remember, like, this would be no solution, or no real solution. Or we can get it to cross. So if the ends began above it or below it and ended up crossing. So those are the possibilities. So you can have 0 all the way up to the maximum possible degree of that solution, or your odd degree, you have 1 and then all the way up to its degree for its zeros. Let's play this. And then remember when we talked about whether you're a turn person or a hill person? I think we discussed that. So that can help you decide what degree you've got. You can kind of predict the power of the polynomial function by looking at the hills, and so you can count the peaks or valleys of your polynomial and then add one, and that will give you your degree. If you're a turn person, like if you can kind of count the lines, so where it's increasing and increasing and decreasing, those turns, that is exactly your degree. And as we go over this together, it'll be a little bit easier to discuss. So, but if you're comfortable with this from when we had talked about it in Unit 1, then you're pretty good to go when we start out right into our packet. So, good luck. I will see you in class, and we will dive right in.